All right, section 4.2, graphing linear equations. There's a lot going on in this lesson, so let me begin by saying a few things. One, you definitely need graph paper. You're going to have a lot of video homework to turn in next class period, so make sure you have graph paper out right now. We're going to be doing about 9 examples, so this lesson is going to be a little bit longer than the other ones, so you need to be patient and go through this with some intentionality. Here are the topics we're going to hit on. One, graphing linear equations using a table or list of values. In other words, using a t-chart. And this is something that you guys did practice in middle school. It's a very important skill and it never goes away. There are many ways to graph linear equations, or in other words, graph lines. This is just one of them. It's kind of an old and reliable method, but it's one that you can always fall back on. So it's good to be well versed in it. We'll also talk about graphing horizontal and vertical lines, so those are some special cases. And then we have some subtopics, like putting equations in function form. We'll review that. You guys went over that in Chapter 3. And also determining whether or not something is a solution to an equation, and doing so graphically. So let's go ahead and hop into it. It says, a solution of an equation in 2 variables is an ordered pair that makes the equation true. The graph of the equation in x and y is the set of all points that are solutions of the equation. The graph of a linear equation is a line. So in other words, when we graph a linear equation, it will produce a line on the coordinate plane. And this is all a fancy way of saying that the solutions to the equation are going to be the points that help construct the line. So if a point is on the line, it is a solution to the equation. If a point is not on the line, then it is not a solution to the equation. And we'll go ahead and do an example of that right now. So you can go ahead and write down example 1 on your graph paper. It says, use the graph to verify if the points 1, 4 and 3, 4 are solutions to the equation 4x plus y equals 8. And here's the picture I'm going to give you. So here's what I want you to do. For this one, you don't need to copy the coordinate plane. If you want to go ahead and write down 4x plus y equals 8, feel free to do so. But I want you to test both of these points. Is 1, 4 a solution? Is 3, 4 a solution? And I want you to do this graphically. In other words, see if the points fall on the line. Okay, and when I'm talking about the line, I'm not talking about the x-axis and y-axis. Okay, that's the coordinate plane. Okay, when we talk about the line or the graph, we're talking about that blue line that's kind of slanted right there. Okay, if the point is on the line, it is a solution. If the point is not on the line, it's not a solution. So go ahead and I want you to hit pause and kind of analyze this for yourself. On your paper, you'll write down 1, 4, and then beside it, write a yes or a no. Okay, yes, it is a solution, or no, it's not. Do the same for 3, 4. So go ahead and get your answers now, see what you think. Don't worry about being right or wrong, just I want you to take a stab at it, and then we'll come back and go over answers. All right, let's see how you did. For 1, 4, did you come up with yes or no? Well, this is actually kind of tricky. You have to study how your x-axis is construction here. Believe it or not, the answer is yes. Okay, and maybe you got that, maybe you didn't, but let's take a look and see what happens here. Where is 1, 4 on the coordinate plane, and does it intersect with the graph? In other words, is it on the blue line or the blue graph? Okay, well, we have to know where 1 is on the x-axis, and if you look closely, this x-axis is skip counting by 2. So this would be 2. I know that because the next one is 4, the next one would be 6, the next one would be 8, so on and so forth. That 4 kind of gives us a clue there. So if we want to graph 1, 4, the 1 is actually right here. Okay, that's 1 on the x-axis. Notice that the y-axis also skip counts by 2's as well. So if this guy is a 2, that means counting up we have 1, 2, 3, 4. So 4 is right there. 1, 4 would be located in this area right here. And notice, as I'm plotting that point, it is exactly on the line. Okay, so if it's on the line, it is a solution. So for 1, 4, the answer has to be yes. it is a solution. This is a graphical approach. There are other ways of doing this. There's an algebraic one as well, but right now I'm asking you guys to do this graphically. Let's see what happens with 3, 4. And I'm going to do this one in a different color. 3 on the x-axis is located here, so 3, 4 is going to be located right here in blue. Is that on the line or off the line? It's off the line. Okay, so since it's not on the graph, it's not a solution. So for 3, 4, we have to answer no. That's the graphical approach. Okay, you can also do this algebraically. Okay, in other words, in the algebraic method, you look at your x and you look at your y, and you plug them in for x and y, and you see if they make a true statement. If they make a true statement, then it is a solution. If they make a false statement, then it is not a solution. And we can kind of take a look at that right now. So for 1, 4, if I plug in 1 for x and 4 for y, 4 times 1 is 4 plus 4 is 8, and 8 equals 8. That's a true statement, so therefore 1, 4 is a solution. That's sort of the algebraic proof. For 3, 4, 4 times 3 is 12 plus 4 is 16, and 16 does not equal 8. So that is not a solution. So notice that anything we can do algebraically, we should be able to also represent graphically. So there's a graphical approach and an algebraic approach, and I say use them both. Okay, so that's one of the subtopics. Here's the major topics. The major topic. One way to graph equations is to make a table of values for the equation. Okay, and we're going to practice this together right now. You should be able to do this. Our task is going to be to use a table of values, aka t-chart, to graph the equation 5x equals y minus 2. Okay, this is going to involve a little bit more work on your paper. So here are the things I want you to construct right now. You can go ahead and write down 5x equals y minus 2. Give yourself some space around that. You can go ahead and set up a t-chart like I've done right here, with an x column and a y column, and I've already chosen the values for you. Usually you're going to have to choose them yourself, and you want to construct a coordinate plane. Now you're working on graph paper, so your coordinate plane should take you no more than 45 seconds. You draw an x-axis horizontally and a y-axis vertically. You can put little hash marks if you want, but do not take 5 minutes to draw one coordinate plane. They need to be nice, neat, but also constructed very rapidly, because we're going to be making lots of these things. Okay, so if you need time, go ahead and give yourself some time to construct this, set this all up. If that means that you need to pause, go ahead and pause right now. But I want you to actually go through this all on your own. So go ahead and set this all up. One thing that maybe we should do before you start is talk about the equation. I'll give you a hint there. I would not use the equation the way it's written right now. You want to put that in function form. In other words, get y by itself, just like we practiced in chapter 3. Get the y by itself, then fill out your t-chart, and then graph your points and connect to make a line. Okay? So depending on where you're at, you can go ahead and try this on your own. If you're not ready to do it on your own, go ahead and construct all of these things, and then you can unpause it to go through it with me together. Either way is fine with me. So go ahead and hit pause now, and then we'll resume to go through the answer to this. Okay, let's see what we come up with. The very first thing you want to do is put this guy in function form. In other words, get y by itself. So I'm going to do a little pre-work to my equation here. I've got y minus 2 on the right-hand side. I want to add 2 to both sides. This is a skill we worked on in chapter 3, so it should be pretty fresh in your head. Okay. Notice that the 2's cancel, and I'm left with y by itself. And 5x and 2 are not like terms, so I can't really combine them per se, but I do get 5x plus 2 on the other side. And then usually we write the y on the left-hand side, so I might go ahead and just quickly invert that and change it to y equals 5x plus 2. Always put that x stuff first. It's going to be a good habit to be in. So this is the equation I actually want to be working with. And notice it's set up in function form, meaning we've got y as a function of x. I can stick a number in here for x, and it's going to spit out a number here for y. That's why we want to do this. It's not as clumsy as dealing with the original one. All right, next up, we want to check the t-chart. In other words, my t-chart should match up with your t-chart. If your t-chart's wrong, your graph is not going to be correct. So now we're going to take the values over here, the x values, and we're going to be plugging them in right here for x. So imagine we plug in a -1 for x. That's 5 times -1 is -5. -5 plus 2 is -3. So you should have -1 comma -3. 5 times 0 is 0. Plus 2 is 2. So 0 comma 2 is going to be my next point. 5 times 1 is 5. 5 plus 2 is 7. So 1 comma 7 will be my next point. And then 5 times 2 is 10. 10 plus 2 is 12. So 2 comma 12. So that's kind of step 2. Step 3 is going to be to represent all of this stuff correctly on the coordinate plane. And you don't want to miss, you don't want to graph one of these points incorrectly because you've done all this other work. So let's make sure we do this right. -1 comma -3 is going to be over here in quadrant 3. So I go 1 to the left and 3 down. And that's -1 comma -3. 0 comma 2 is right up here on the y-axis. 1 comma 7 is over here in quadrant 1. And so far I'm liking this because everything's lining up. After I've got my third point, I can see, that things are sort of lining up in one direction. If my next point were to be like way out here, then I would start to think, okay, maybe I've done something wrong. But I know that this is a linear equation. It's supposed to graph a line, so I expect things to line up. Okay, 2 comma 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is all the way up here. Okay, and those points kind of support each other. So I like the fact that everything lines up, and I'm ready to draw my line. Okay, so you want to connect all these with a straight line if possible, as straight as you can. And then one thing I ask you to do is to, if we're graphing lines, always put arrows at the top of your lines. Those imply that this goes on for infinity, and lines by definition go on for infinity. Okay, so hopefully this matches up with what you had, or maybe you just walked through it with me. You also want to look at this line and maybe start making some opinions about it. For example, would you consider this to be going up or going down? You might not know the answer to that question yet, but this is definitely going up. From left to right, this line is going up. Would you consider this to be a steep line or a gradual line? Okay, and hopefully you see this as a steep line. It's going up in a very steep manner. Okay, that'd be a very steep cliff side of a mountain, if you can imagine that. Okay, so that's example 2, graphing a line using a t-chart. Very, very important skill. You're going to get a lot of practice with that here coming up. All right, let's move on to the next topic. And this is one that's going to pop up in geometry next year and that you just need to know. These are kind of special cases, okay? So horizontal lines and vertical lines. It says the equation for a horizontal line is y equals a number, okay? So something like y equals 1, y equals 7, y equals -10, okay? In horizontal lines, the y value will never change no matter what the values for x are considered. So the y values in the x comma y will always be the same number. Okay, and we'll go over that in a second. The opposite is true for vertical lines. For vertical lines, the equation is x equals a number, like x equals 2, x equals -3, x equals 5. Okay, that's going to create a vertical line. In vertical lines, the x value will never change, but the y ones can be whatever. Okay. All right, let's take just a brief look at this, and you don't have to copy this down. I just want you to kind of look at it and try to think about it. I'm just going to draw a very, these are going to be a little clumsy. I'm going to draw a very brief coordinate plane here. Nothing too complicated. Same thing down here. And let's take a look at a horizontal line. So for example, let's maybe contemplate something like y equals -3. What does that mean? Okay, well, on the coordinate plane, that's going to be a line. It's going to be a horizontal line. And we want to think about this maybe in terms of x comma y. If we're saying y equals -3, What we're really saying is that this value here will always be a negative 3. We might not know what the x is. The x could be any number you want. But the y value we're going to hold constant at negative 3. Okay? Well, imagine what that's going to look like on the coordinate plane. If we go down to negative 3 on the y-axis, which is about right there, okay? Just imagine some points in your head. For example, this point here is 0, comma, negative 3. 1, comma, negative 3 might be over here. 2, comma, negative 3 might be right there. 5, comma, negative 3 might be right there. 6, comma, negative 3 might be right next to it, right there. Negative 2, comma, negative 3 might be over here. When we hold the negative 3 steady, we always go down 3. And when we always go down 3, things line up in this nice, neat horizontal line. So that's why y equals a number is going to produce a horizontal line. Okay, let's look at the other side of that with vertical lines. Vertical lines, we use the setup x equals a number. And let's try one like, maybe we'll try x equals 5. Let's think about what that means in terms of x comma y. If x equals 5, that means we'll always hold the x to a 5 right there. So we don't know what the y is going to be, but it's going to be 5 comma some number for the y. Okay, so you can even just make up some values in your head and see how these are going to fall. So if we had to go over to 5 on the x-axis, we'd end up about right there. 5 comma 0 would be right here. 5 comma 1 might be right there. 5 comma 2, maybe 5 comma 4, maybe 5 comma negative 1, 5 comma negative 2. When we hold that 5 constant, we get these things lining up in a straight line, but vertically. So if you want to make a vertical line, x equals a number. If you want to make a horizontal line, y equals a number. Okay? All right, so now I'm going to ask you to try some of these on your own. Go ahead and on your graph paper, I want you to construct one coordinate plane, x-axis, y-axis. Some hash marks are optional, but remember, do it in 45 seconds or less. And for this one, usually I like you to have one graph per coordinate plane. I'm going to ask you to graph 2 different ones on this one. It's usually not the case. But these are the ones that I want you to try. Okay, and we'll color code these. So I want you to try x equals 2. Try to graph x equals 2. And then when you're done with x equals 2, I want you to graph y equals 4. So you're going to get 2 separate graphs on the same coordinate plane, and let's see if you can keep those. Let's see if you can differentiate the horizontal one from the vertical one. If you need to go back and look at your notes, that's fine. Okay, so go ahead and do this on your own. Hit pause now if you need to, and then when you're done, you can go ahead and unpause. We can reconvene to go over answers. All right, well, x equals 2 is going to be a vertical line, and it's going to be a vertical line that crosses the x-axis at 2. So hopefully you got this for x equals 2. Okay. Y equals 4 is going to be a horizontal line that crosses the y-axis at 4. So y equals 4 will be the horizontal line here crossing at 4. And just to kind of quickly review what we just went over, if you look at the x equals 2, notice that this is 2 comma 0, 2 comma 1, 2 comma 2, 2 comma negative 1, 2 comma negative 2. That front 2 is always being held constant, and that's how we get the vertical line. Notice for y equals 4, this is 0 comma 4, 1 comma 4, 2 comma 4, 3 comma 4. That comma 4, the y coordinate is always being held at 4, so that's how we line up and get that horizontal line. All right, good job with that. We're going to move on to something else. Example 4, and this you already know how to do, so this is review. To rewrite an equation in function form, solve for the y variable. Okay, so let's see if you remember from chapter 3, and we already did this back on example 2 a little bit, you have an equation 3x plus 5y equals 6. And I want you to take this and write it in function form, getting y by itself. So go ahead and go through the process of whittling this thing down to y equals some kind of x plus or minus some kind of constant, and see if you can get that y by itself. So go ahead and try that on your own, write that on your paper. Go ahead and hit pause now. We'll reconvene, see if our answers match up. All right, let's see how we did. First step, you're going to take away the 3x. So in order to get that y by itself, you're going to have to subtract the 3x from both sides, and then we'll deal with the 5 in the second step. So these x things are going to cancel out. And notice 6 minus 3x, those are not like terms. You're going to rewrite this as 5y equals, and I do like you to put the x stuff up front. So put the negative 3x up front, and that's a positive 6 up here. So negative 3x plus 6. That's kind of step 1. Okay. Step 2, how is that 5 glued to the y? Well, it's multiplying the y. We're going to divide it away. You divide the left side by 5, you divide the whole right side by 5. So with multiplication and division, it happens to the whole entire side. And here you're going to be left with y equals, and here's where you have to go back to that Hart method. Okay, so negative 3x divided by 5. Remember, I want you to write that as negative 3/5 x. I like you to do that fractional coefficient thing. Okay, negative 3/5 x, and this is positive 6 divided by 5. And that's going to be plus 6/5, plus 6 over 5. Okay, and that is your function. So yeah, you have fractions. It's not, you know, nice and easy whole numbers, but that's life. Okay, life is fractions and decimals. So y equals negative 3/5 x plus 6/5. Hopefully you all got that. All right. Now I'm going to give you some more independent practice. So go ahead on your graph paper, give yourself some space, or even go to a new page if you need it. We're going to go